Today we'll be learning about factoring difference of squares. So when we're talking about difference of squares, remember that difference is a word that we use for subtraction. So let's just really quickly remind you how when we are multiplying binomials, we end up with usually a trinomial. But in the case of difference of squares, the middle term is eliminated. So if we FOIL this, x times x is x squared, x times -9 is -9x, 9 times x is positive 9x, and then 9 times -9 is -81. Then we have these middle terms that are like terms, and we should combine them. And when we do that, they cancel out. So we end up with x squared minus 81. So what we have here is a difference of squares because x squared is a perfect square and 81 is a perfect square, and they are being subtracted. Second example, we would have 25x squared plus 35x minus 35x minus 49. And again, our middle terms would cancel out. 25x squared minus 49. I'll do one more example. 4a squared minus 6ab plus 6ab minus 9b squared. Middle terms cancel out, and we end up with 4a squared minus 9b squared. Now, we are factoring in this objective, so we are wanting to reverse that, but we can just memorize the rule for difference of squares. So what we just did in those examples was we multiplied and we got a squared plus ab minus ab minus b squared. Middle terms canceled out. So our answer is a squared minus b squared. So what our rule is to reverse that is that if you have two perfect squares that are being subtracted, which is a difference of squares, it will always equal the square roots subtracted and added. So this will always be your answer. A squared minus b squared equals a minus b times a plus b. Okay, so let's also quickly talk about a sum of squares. So if perfect squares are being added, the same rule does not apply. Because if we take the square root of the first term, which is x, square root of x squared is x, and the square root of 4, you can put that in your calculator. Square root of 4 is 2. You could say, okay, well, is it x plus 2 squared? Or x plus 2 times x plus 2? If we multiply that out, we end up with something completely different. We end up with x squared plus 2x plus 2x plus 4. When you add these together, they do not cancel each other out. you end up with x squared plus 4x plus 4, which was not what we had originally. So sum of squares, remember if there's a plus sign, that's not going to work with this rule. So there's no rule for x squared plus 4 because it's not factorable. Okay, so make sure you have an actual difference of squares would be the first step. Make sure that they are perfect squares, meaning you can take the square root of both terms and they're being subtracted. And then you're going to apply the rule to factor a squared minus b squared. You're going to, take the square root of each term, write both terms in a set of parentheses, make the sign of one set of parentheses positive and the other negative. And then you can always check your work by distributing again and make sure you got that original answer. So let's go through some examples. And I know it looks like a lot of examples, but this is really quick. So we'll say that this term is A and this term is B in our rule. So you need to just remember that the square root of x squared is x, because x times itself is x squared. If you want to use a calculator for the second term, 64, you can take the square root of 64. You'll end up with 8. So then I'm going to write two sets of parentheses. I'm going to write x and 8 in both. And I'll put a minus in one and a plus in the other. It does not matter which comes first, as long as one's minus and one is plus. Let's look at number 2. We'll have 81ba and x squared b. Take the square root of 81. That's 9. And the square root of x squared is x. So don't change the order of a and b. That's very important. So we have 9 and x. And we'll make this one plus first and then minus. So the order of plus and minus does not matter, but a and b must stay in their same positions. Okay, what if there's a coefficient of x? As long as it's a perfect square, this will work. So we'll take the square root of 9x. You can put the square root of 9 in your calculator, but you can't put x squared in your calculator. Square root of 9 is 3. Square root of x squared is x. Square root of 100 is 10. So we have minus and plus. And if I were to FOIL these, I would end up with 9x squared minus 100. And that's how you can check your work if you want to. Okay, let's take the square root of 16x squared and the square root of 121. Square root of 16 is 4, and x squared is x. Square root of 121 is 11. Right, what if we have two variables here? Take the square root of 36x squared, which is 6x, and the square root of y squared, which is y. Number 6, take the square root of 4x squared. Square root of 4 is 2. Square root of x squared is x. And the square root of 25y squared is 5y. Okay, number 7. The square root of x squared y squared, that'll just be xy. And the square root of 1 is 1. Let's look at number 8. We actually cannot factor this. Did you catch that? This is not a difference of squares. It's a sum of squares. So be careful that you don't try to do apply a difference of square rule to a sum of squares. Okay, let's look at 2 more examples. One that has a greatest common factor, because remember, you should always be looking to see if both terms or all terms in the polynomial have a greatest common factor. In number 9, I can see they're both even, so I can definitely factor out 2. And then after I factor out 2, I see I have a difference of squares. So now I can take the square root of x squared and the square root of 36. Now just don't forget that you have to bring down that 2 and make it part of your answer. Okay, last example. Find a greatest common factor. I can see I can divide both of those numbers by 5, and they both have x. The lower exponent would be 1, so I can factor out 5x. This would be 9x squared minus 4. Which is a difference of squares. Square root of 9x squared is 3x, and the square root of 4 is 2. So my answer is 5x times 3x minus 2 times 3x plus 2. So that's what you'll be doing in today's practice.